Okay, so we're in Robot C, and the first things that I want to remind you guys about are just getting things set up. First off, we want to make sure that we're in the right robot platform. So come up to where it says Robot at the very top, click there, and then we want to make sure that our communication mode, right now, we can go ahead and use USB only. And the VexNet, those are the little white USB things that I put in your joystick boxes or your remote controller boxes. We're going to not worry about those for right now. We're just going to focus on using your orange USB cord. That's going to allow us to have just fewer things to troubleshoot if we're connecting it hardwired with the cord instead of trying to use the USB. So we'll click USB only. Let's come back up to robot. We're also going to change, so our compiler target is the physical robot. That's our only option. That's what we want. We also want to make sure our platform type is selected VEX 2.0 Cortex and that natural language has a check mark next to it. These we set up when you came in to visit, so I think that they will probably still be set up right now. The other thing that I want you to be aware of here is where it says download firmware. This button, the first one where it says automatically update VEX Cortex and automatically update VexNet Joystick. So the Cortex is your brain, like this one that I have on my robot. The joystick is referring to the remote controller. And if you have either the Cortex or your remote controller connected to your laptop with the orange cord, then whichever one is in there, it will automatically, if you click this firmware download button, that's the same thing as clicking automatically update VEX Cortex or automatically update VexNet Joystick. The last thing here, that is your manually update firmware. So if you try doing a firmware download and still things are not working properly, this is when you can actually come back in and completely rewrite, do a master rewrite of your Robot C firmware, which is the program running on your computer, the CPU firmware, and that's referring to the Cortex, and then the joystick firmware, the remote controller. And what these do, the manually update, these are going to actually just rewrite the programs on all of those. So it's back to factory settings, no changes, no user changes are saved. And that allows, if there's just bugs in any of the programs, it allows those bugs to get completely cleaned out and it's completely refreshed. So if you get to a point where even doing your regular firmware downloads is not helping to solve a problem, those master downloads, doing that, again, robot firmware and then manually update firmware, those ones, especially the master CPU firmware download that goes onto your Cortex, those are going to be the most helpful things to get things reset. Okay, now that we've gone over those basics, let's go ahead and come up to File, and we're going to open a sample program. And I'm going to have you guys go down to remote control. That's going to be the first thing that we want to try to do with your robot, is to just check that the remote control connects and works properly. Click open that folder. And then I think let's go ahead and do a Clawbot single joystick control. This one here, that's the second option. Different from one of the ones that we did when you guys were here over spring break or before spring break. So Clawbot single joystick control, I want you to select that and click open. Okay, and this, what you see up here, the way that this is all set up, this is telling you what ports on your Cortex all of your different motors are going to be plugged into. And we don't have the full Clawbot created yet. We so far just have your base robot, so just this little guy. And mine, if it looks wider than yours, that's because it is, because I just used longer angles to make sure that I could give you guys the appropriate angles for building your Clawbot, but it really doesn't matter that much. Mine's just a wide base. Maybe makes it a little bit more stable, actually. But we're just going to practice plugging things in and checking to make sure that the motors are in fact functioning. So even if you don't have motors properly plugged into both sides, we can still plug our motors into the Cortex and check that they are turning on and running. Okay. So first thing that I want to talk about is just how all of this stuff gets set up if we're not doing a program where we're just using a sample program. And that is this button up here that says Motor and Sensor Setup. If you click that, so this is taking us to the digital ports. And we'll get into the digital ports when we do things like using your limit switch or using your sonar sensor, some of these other things that I put into your box that are not part of the Clawbot kit. If we come back over to the analog sensors, there's some other different types of sensors that you can use here, like the line follower is one of those. You have a couple of these line followers in your toolboxes. We'll get to those later in the semester. And then if we get back over here, you'll see motors. And these are the only things that are set up in here right now. One thing I want you to do on this default, you have, for all of your motors, you have this type right here, which is going to say, I think it's showing you me backwards, but it says 393. Maybe it's just showing me, and when it does the final version of this, it'll be right side for you, I hope. But in any case, your motors all say 393, so we're going to change this particular one where it says VEX 269. Go ahead and change that to VEX 393. And then all of these are now saying 393. That's what we want. I also want you to notice that there's an option that says reversed. So think about why we might want to have our left motor and our right motor not going the same direction. So if you think about that, if your motors are going the same direction, but we have them facing like this, you end up having motors that are actually going opposite to each other if they are facing opposite directions. So if we have one of them clicked to be reversed, then they'll be able to go the same direction. What might be a little tricky though is what if we start this and we've actually picked the wrong one to be reversed, and when you're driving it around, you have to press backwards to go forward and forwards to go backwards. Well, if that happens, all you have to do is come back into this motor and sensor setup and switch the other one to be reversed, re-download that program, and that should have them going the correct way. So don't worry about that right now. We'll test it out and then we'll see if we need to make a change. There's also this first tab here that says standard models, which you can use. They actually have a Clawbot as a standard model in here, just like this. So you can use that standard model, but we don't necessarily have to. So we're just going to go ahead and use exactly what is here, and we'll click OK. If you click apply, that'll just send the settings to the program, update the program, but not close this window. But if we click OK, it'll send the settings and it'll close this window. So I'm going to do that. And then the next thing that you see here, so now this says standard model RVW Clawbot, which if we look back at our motor and sensor setup, that's everything here is still the same. It has added some different sensors in here that we can play with later on, but we don't have to worry about them right now. Okay. Now, if we take a look at this, it has all of the information about where our motors are. Oh, this one is actually putting our right motor in port 2. Let's go back and just double check that motor and sensor setup. Motors, no, it's still putting left motor in port 1, right motor in port 10, and then claw and armor in 6 and 7. So That does seem to be incorrect. Let's go ahead and we can fix this. It said, one more time, left is in port 1 and right is in port 10. So right motor, that was port 10, and our left motor is actually in port 1. And all of this stuff that's in green, you see how the first line has these 2 slash marks. Whenever you start typing, if you type 2 slash marks at the beginning, it's going to change it to green. What we call this is pseudocode. This is the code that is just for humans to read. The computer just skips over anything that is pseudocode. It doesn't care about it. And it's just to help humans to look at this and understand more easily what the program says. And then if you want to have, instead of just a single line be pseudocode, if you want a whole paragraph to be pseudocode, you start out with a slash and then a star, and then everything that you want to be pseudocode is going to be green on every single line until you get to a star slash, and then it'll be over. So after this line, if I added something after here, it's still going to be pseudocode. But then if I go down here and I start typing, see how that is not pseudocode anymore after you end with a star slash. All of the other little like straight line stars on either side of this, those are actually just to kind of make a little box around this for decoration, really. They're not necessarily, they don't actually have to be there. Like I could get rid of these lines here and it would still work just fine. So just to show you a little bit about how pseudocode works. Then this line, the only reason that those plus signs are showing up like pseudocode is because there was the 2 slashes at the beginning. Now, let me deselect. There we go. Okay, now this is going to tell me about my remote controller. And I am a bit of a goof because I gave you guys, I just had 3 controllers. So you guys actually have all of my controllers now. But I'm going to try to, we looked at them together, so I think it'll be okay that you guys have already looked at how the joysticks are lined up. You saw what the different channels were. So I think that you gentlemen will be just fine figuring this part out. So the beginning line here where it says task main and then there's 2 parentheses, open close, that has to be at the beginning of every single program. And then the next thing here is this open curly bracket. So if you look at that, it's this open curly bracket, the one where you have to click shift. If you don't click shift, it's a square bracket, but then if you click shift, it's going to give you the curly bracket like that. That is our first, this is where we open up where the rest of the program is going to get written. Every single program that you write is going to need that curly bracket. Then after that, this is opening up what's called a while loop. And so what this means is while 1 is equal to 1, everything inside of this next curly bracket is going to happen. Well, while 1 is equal to 1, 1 always is equal to 1. This is a way of saying a forever loop of we want this to just continue to repeat forever until we turn off the robot. So that's why it's 1 is equal to 1. That's a strategy to just make the program continue to run again and again and again. So what is going to happen then is just consistently, as quickly as the robot can read the code, it will go through the code and then it will go back up to the top and do it again and do it again and do it again. And that's how your remote controller is able to continue to function, and it doesn't just do one thing and then stop. So what then it's going to be looking for, it's going to set your left motor to be controlled by channel 2 and channel 1, and your right motor is also on channel 2 and channel 1. So basically your joystick is controlling both of them. It's going to control going forward and backward and side to side with just one joystick, the one that says channel, the ones that are channel 2 and channel 1. So if you look at your remote controller, you'll see which joystick that one is. I think it's the one on the right, I'm pretty sure. But take a look at your joystick and check my memory. Next up, we have the information about the arm, and that is where you're going to be using the buttons that are on the front side. I'm pretty sure it's 5 and 6, but take a look at your remote controller and double check. So your arm motor will be using button 5, and there's an up one and a down one. And then the same thing for your claw motor, button 6, up and down. And I also want you to remember, okay, so here are the different ports that we need to be plugged in. So whenever we are referring to claw motor or arm motor or left motor or right motor, what this program is telling our computer to do is to identify right motor as whatever thing is plugged into port 10. Because it doesn't really matter what the name of this is. We could call this, you could call it right side. You could call it right wheels. You could even call it Jeff. It doesn't matter, as long as we come back here and we say, okay, for our, I think that was our, yeah, that was our right motor. As long as we change wherever it says right motor, if you change that to say Jeff, then it will refer to the correct thing. And another thing that can be really helpful when you're writing your own programs is clicking this button, the fix formatting. If you click that, it'll kind of order things in correctly. Did I even? Yeah, that's the right one. I don't know. Sometimes it doesn't like when you start something with a capital letter. We could call it maybe Jeff motor. Let's try that. And then if we come down here and we call this Jeff motor, I think that should work. Let's try compiling that. Yeah, okay. See how Jeff motor is now that dark red color? That means that it's reading Jeff motor properly. So that's just to demonstrate to you it doesn't actually matter what you name them as long as you're referring to them consistently. And it does help to start with not a capital letter, and you wouldn't want to refer to it as like motor 1 or motor right. You don't want to start it with the word motor because motor is actually used, if we look at some of our other commands, it will actually get used in other places. So if the start of the name of something is motor, it will get confused with this particular command over here. So we don't want to do that. But anyway, now we've looked at this program a little bit. So the next thing that we need to do is actually look at our physical Cortex. So I'm going to go ahead and pause here and then record with my physical robot for a minute. Okay, so now here is our physical robot. And if you haven't attached your Cortex to your robot yet, that's okay. You don't have to have had it connected yet. But I have my battery down at this end. And you've probably noticed that when you try to take the battery out, it does require some effort. Don't be afraid to really give it a tug. You've probably already noticed that one of those is square and one of those has a side that's rounded. So when you look at the front of your Cortex, you can see which way you need to plug that in. Let's go ahead and we can plug that battery in, though we don't need to get it turned on just yet. And then the next thing I want to take a look at is where we're going to be plugging in our motors over on this side. I'm going to try to zoom in on that a little bit more. Okay,
This is where it's important to be able to read carefully. I think at least one of you guys has this part that like holds those into the ports. I think at least one of you has one that's broken off, which is fine. Sometimes I kind of prefer that because it's easier to get things in without having to hold this back. But notice that port 1 and 10, those are the ones that only have 2 holes in it for these 2-wire motors. And then the rest of the ports have 3 holes. And the ones that are going to have 3 holes, those are the ones that will be using these, which will connect on one end to the motor and on the other end to your Cortex. And if you can remember back to what I said about that, it's because the motor controllers, those are what allow your controller to regulate how much electricity is going into the motor. If you don't use one of the motor controllers when you're using ports 2 through 9, then it'll just be motors receiving electricity, so it's going to turn, motors not receiving electricity, so it'll stop. And you won't be able to control the speed or the direction. But ports 1 and 10, they already have that built in, so that's why in ports 1 and 10, we don't need to connect one of these to it. The idea is to make ports 1 and 10 just easy for you to plug into. Another thing that you can do, if you find that you're going backwards, you can actually switch where these 2 are plugged in, and that'll change the direction, because remember how we used the reverse button to change that instead of them going the same direction, so that when they're facing each other, they're going opposite directions. If one of them is reversed, then they're going to be able to go the same direction, even though they're facing opposite directions physically on the robot. So we've got those 2 plugged in. The other 2 motors, which we have not mounted yet because they are going to be on your arm and your claw, we're just going to test that they actually work. So that way, in case anybody has a motor that has stopped working since we tested them in class, we can get those replaced for you. So this is going to be where you need to take a motor and connect it to one of these little guys, a motor controller. And, oh, I just discovered I have a motor that is missing a prong. So that is probably not going to function, but I'll just demonstrate. Plug that in. Go ahead and you can plug it red to red. And the same thing on this one. What do you think might happen if you plugged it red to black instead? Well, if you plugged it red to black instead, then it would just be sending the electric current through your motor the opposite direction, so it'll turn the opposite way. That's another way that you can control turning them around. So we wanted to have our claw arm and our claw motor and our arm motor plugged into ports 6 and 7. So I usually count up from the bottom, 9, 8, 7, and try to make sure that there's 2 gaps, and it looks like I've got 3 gaps there. So if that's 10, then the first gap is 9, 8, 7, because they're not perfectly lined up. So I've actually plugged this one into port 6. So port 6 is, if I look back at my program, port 6 is the claw motor. So then if I take my other one and plug it in just below, that's going to be in port 7, and then port 8 and 9 are empty. And then port 7 is going to be my arm motor. So now that I've got these guys plugged in, I will be able to actually download the program to my Cortex and then test the program.
Okay, now it is time for us to actually download our program to our Cortex. So you're going to take your orange cord, connect it to your computer, and then over here on your Cortex, remember that you plug it into the top of your Cortex. There There we go. And you'll probably see a little light turn on, and you'll also probably notice that the robot light is red and the VexNet light might be green. If that's the case, that's just because your Cortex is still powered off right now. That's why the robot light is red. Don't worry, you don't need to have it turned on right now because it's still just getting a program downloaded to it. Right now, the Cortex is only powering because it has electricity going to it from our orange cord and not from the battery. Now we're going to go ahead and click download program or download to robot. What this will do is actually both compile and download, as you can see in the description there. Compiling the program just means that it checks your program for errors. That's what that means. It makes sure that the computer is going to be able to read it. So if we click then download to robot, it'll do both of those things at once. There we go. It'll take just a moment. And, oh, okay, so this says power cycling is required. Uses a different communication type than download only. Download using VexNet or USB. Okay, so that is fine. Once you've power cycled the Cortex, then, okay, that's fine. We can do that. So power cycling, what that means is we need to, well, I'll show you that in person, just a moment.
Okay, so what power cycling means is we are actually going to turn the robot all the way off. Let me focus that again. Okay, so we want to unplug it so that the lights are no longer blinking, and we're even going to unplug it from the battery, because sometimes even though it's turned off, if there's still a battery connected to it, there is still some electricity that can pass through this, so we want it to be completely shut down. Now I can plug it back in and plug my USB back in up here, and now we'll go back over to the computer.
Okay, so I have plugged my battery back in, and I am going to go ahead and click up where it says robot, communication mode, let's use VexNet or USB. And now we'll go ahead and click download to robot again. And this time now, okay, so now it's working. There we go. Okay, had a few little things happen here. We are now looking at the debugger window. And so I'm going to move my face over here so that you guys can see what's going on this side. I think it's kind of funny that the line follower is actually showing up with any data at all because there's not one plugged into it. We're going to just focus on the motors. So if we look down here at this tab with the motors, then we can actually see at a given time what the motors are doing. The only problem is that we can't really test the motors without the remote control right now. So this isn't really going to give us a whole lot of data. But this is just the debugger window, and we'll be using this more when we actually get to programming the robot to work autonomously. At this point, you guys just need to try testing your robot with the different buttons on your joystick. And what I need to know from you guys today is, are there any buttons that don't appear to be working? And if you continue to have problems, I'm going to go ahead and close the program debug window. I'm going to close that, and that'll take me back to the regular program. If you find that any of your motors are not working, what I want you to do is try putting your motors into different ports on the Cortex, on here, and then you'll have to come in to motor and sensor setup over here, and you'll have to change what port it's in. So let's say that the motors that you plugged into port 6 and 7 are not working, what you can do is highlight that and then do Control X to cut, and then maybe you try it in port 4 and you do Control V to paste, and we change this to say 393, and we change this to say no motor, and then we would go OK and try that again. We can go back into motor and sensor setup, and we can um, uh, choose, ooh, I guess, well, we don't really need all of those, but I'm not going to bother going back in and deleting all of them. Um, if you don't like having all of this stuff in here, then you can always just go back into File and open up a new program or open up this single joystick again. You might also save, just click Save or Save As to save it differently. And if you have any trouble saving, I would recommend saving it to either Documents or the desktop of your computer, and give it a different name. You can say like Joystick Test 1, something like that, to help you keep track of what assignments you're working on. So your goal right now is just to test that all of the motors that you have are functioning. I would also go ahead and take your claw setup that has a motor connected to it, test that motor out as well. Remember that one, so you have, including the claw, you have a total of 5 motors so that you have some backups. So test all 5 of them, including the one that has the claw. The claw does need to have this motor connector, okay? And then what I need to have from you guys today is just what results did you get? Were you able to get all of your motors to work properly? Did you have to change any of the ports? And so log back in at the end of your block today to let me know what your results are. And that is all for today's lesson. Thank you, gentlemen. Bye.